Good afternoon, dear students. Today's class we will learn about frequency distribution. What is frequency distribution? In your high school classes you have learned about frequency distribution. Frequency distribution is a systematic presentation of the values taken by a variable along with the frequencies. It is a systematic presentation of the values taken by a variable along with the frequencies. What does frequency refers to? Frequency refers to the number of times an observation is repeated. In further examples you will come to know what it is. So I will be explaining just the definition. Frequency distribution means it is the systematic presentation of the values taken by a variable along with the frequencies. Now frequency will refer to the number of observation repeated or number of times the observation is repeated. It is referred to as a frequency. The number of observation corresponding to a particular class is known as class frequency. The number of observation corresponding to a particular class is known as a class frequency, and class frequency is a positive integer including 0. Class frequency is a positive integer including 0. These are the three things which you need to remember under frequency distribution. Frequency distribution is a systematic presentation of the values taken by a variable along with the frequencies. Frequency refers to the number of times the observation is repeated, and the number of corresponding observation to a particular class is known as a class frequency, and class frequency is a positive integer including 0. Next we shall learn about the types of frequency distribution. There are two types. They are discrete frequency distribution, continuous frequency distribution. Discrete frequency distribution and continuous frequency distribution. We shall move on to discrete frequency distribution. What is discrete frequency distribution? While framing a frequency distribution, if class intervals are not considered, it is called as discrete frequency distribution. While framing a frequency distribution, if class intervals are not considered, it is called as discrete frequency distribution. Now see the example there. The number of families according to the number of children. The variable here is the number of children to the number of families. Number of families according to the number of children. So they have given the number of children, that is 0, 1, 2, 3, 4, 5, 6. A family containing 0 number of children are 10 families. The children containing 1 child is 40 families. The children in a family, 2 children in a family, there are 80 families. 3 children in a family, there are 100 families. 4 children in a family, there are 250 families. 5 150 and 6 50. So the number of children is a variable and frequency is number of families. So with respect to the number of children, we are going to see the number of frequencies. They are nothing but the number of repeated families. They are 10. For 0 children there are 10 families. For 1 child there is 40. For 2 children there are 80. For 3 children there are 100 families. For 4 children there are 250 families. For 5 children there are 150. For 6 children there are 50 families, and in total there are 680 families. Next we shall learn about the formation of discrete frequency distribution. This is the important thing. We should know how to form the discrete frequency distribution. In the example you can easily understand just the brief introduction regarding the formation of a discrete frequency distribution. Now in this discrete frequency distribution, 3 columns are formed: variables, tally bars and frequency. In these three columns are formed. First one is a variable, second one is tally bars, and third one is about the frequencies. In the first columns, values of the given variable are written without repetition in an order. For each value, a tally or a stroke is marked against that value in the second column. In this way, tally score are marked for all values. For easy counting, the tallies are put as a group of 5. 4 parallel lines you can see, and over that one sleeping line. So finally count the number of tally bars corresponding to each value of the variable in the third column. It is known as frequency, and the total frequency capital N is equal to the total number of observation. The total number of observations should be equal to the total number of frequencies. So 3 columns you need to make in the whenever you form a discrete frequency distribution. 3 columns you need to form. First one is for the variable, second is for the tally bar, and third one is for the frequency. We shall see an example. In a survey, 40 families in a certain locality, the number of children per family was recorded and following data were obtained. In a survey of 40 families, there were 40 families, the number of children per family was recorded and following data were obtained. So you can see the number of children. There are 1, 0, 3, 2, so on. You see the lowest value and you see the highest value. Lowest value is 0 and the highest value is 6. So the number of children, the variables are of the number of children with 0, 1, 2, 3, 4, 5 and 6. So the first column is for the variable. In that the variable is number of children. Next, second column is of tally marks. So how many 0 children are there? You have to find the families with 0 children. So there are 3 families. So mark the lines, that is 1, 2 and 3. Similarly write the frequency. So you see the total will be equal to 40. So this value 40 is equal to the total 40 families. Next, moving on to the example 2, the number of teaching staff working in 20 different colleges was recorded as follows: 15, 12, 18, 10, 15, 12, 20, 25, 18, 10, 15, 12, 15, 20, 25 and so on. You are asked to prepare a frequency table. They have not mentioned whether it is discrete or continuous. So you need to prepare a frequency table. Since it is under discrete, you can consider, but in the examination point of view, you should know how to identify it. See there the solution. So the difference between the highest and the lowest value in the data is very less. You see the highest value, and to the lowest value it is very less, and the numbers of repeated values are also less. So use discrete frequency table. It is known as frequency. The total frequency n is equal to the total number of observation. You see the number of teaching staff, you take it as a variable. There are 10 staff, 12 staff, 15 staff, 18 staff, 20 and 25. Second column will represent your tally marks and third column is the number of colleges. So tally marks 18, 10 there are 2 colleges, 12 there are 3 colleges, 15 there are 6 colleges. So 5 you have to group in one and rest one will be a separate one. 18 there are 4 colleges, 20 there are 3, 25 there are 2 colleges. So in total there are 20 colleges. In total there are 20 colleges. Next we shall move on to the continuous frequency distribution. Now what is continuous frequency distribution? While framing a frequency distribution, if class intervals are considered, it is called continuous frequency distribution. While framing a frequency distribution, if class intervals are considered, it is called continuous frequency distribution. Example they have given: weight of a person in kgs they have given. So weight in kgs they have given from 30 to 40, 40 to 50, 50 to 60, 60 to 70 and 70 to 80. So the number of persons between 30 to 40 there are 10, 40 to 50 there are 15, 50 to 60 there are 40, 60 to 70 there are 45 and 70 to 80 there are 20. So in total there are 130 persons with the certain weightages. Next we will learn some of the terms under continuous frequency distribution. These are important to know what is how the continuous frequency distribution is formed. So the first term is the range. These all things you have learnt in your school life. So but we will just recall range. What is the range? Range is nothing but it is the difference between the highest and the lowest value in the data. Range is the difference between the highest and the lowest value in the data, and range is equal to highest value HV. It is represented as HV minus lowest value LV. So range is equal to HV minus LV. If you remember this, it is enough. Next, class. Class is nothing but the sub range is called as a class. The sub range is called as a class. These definitions as well as some of the problems will be asked for 1 or 2 marks. So students, be thorough with these definitions. Next, class limits. What is a class limit? The lowest and the highest value which are taken to define the boundaries of the class are class limits. The lowest and the highest value which are taken to define the boundaries of a class are class limits. The lowest value is called lower limit and the highest value is called the upper limit. The lowest value is called as lower limit. It is abbreviated as L dot L, and the highest value is abbreviated as upper limit UL, which is the upper limit. So just see the example they have given just for your understanding. The 30 to 40, 40 to 50 are your class limits. Now the lowest value of the class is called lower limit, which is 30 and 40, so on. These are also called as lower limits, and the highest value of the class is upper limit UL. It is 40, 50 and so on. Next, moving on to the types of class limits. These are 2 types of class limits. They are nothing but inclusive and exclusive. What is inclusive now? In a class, if lower as well as the upper limit are included in the same class, such a class is called as inclusive class. If lower limit as well as the upper limit are included, then it is called as inclusive. Here the upper limit of a class is not equal to the lower limit of the next class. Just see the example there. Consider a class interval from 0 to 9, 10 to 19 are your inclusive classes. See there, 0 to 9, 9, 10 to 19. 9, the upper limit of the first class interval, that is 9, and the lower limit of the next class, that is 10. So both are not the same. So if such type if you found, these are known as inclusive class intervals. Next is exclusive classes. In a class, if the lower limit is included in same as the upper limit is excluded from that class but included in the next class, such a class is called as exclusive. Definition may be difficult to understand, so better understand with the examples. 30 to 40, 40 to 50, you see the upper limit of the first class, it is equal to the lower limit. So 40 and 40. If you find these type of class intervals, then it is called as a exclusive class interval. Next, correction factor. Whenever you find inclusive class interval type of problems, you have to convert first into the exclusive, then you need to solve. So how to convert this? We are going to use a correction factor. This is helpful only for the inclusive one to convert it into exclusive one. Correction factor, it is a half of the difference between the lower limit of a class and the upper limit of the preceding class. Lower limit of the class and the upper limit of the preceding class. Thus the correction factor is equal to lower limit of a class minus upper limit of the preceding class divided by 2. Lower limit of a class minus upper limit of the preceding class divided by 2. To get exclusive class intervals from inclusive class intervals, add correction factor to all the upper limit and subtract correction factor from all the lower limits. So to convert exclusive, to get it into the exclusive form, what you have to do is you have to add 0.5 or you have to add the correction factor to the upper limits and you have to subtract correction factor with the lower limits. See the example. Convert the following inclusive class interval to exclusive class interval. Now see the example given. Convert the following inclusive class interval to exclusive class interval. Interval is given, only the class interval is given. CI 10 to 19, 20 to 29, 30 to 39, 40 to 49. You see the first class interval and the second class interval. The upper limit of the first class is not same as the lower limit of the next class. So what you have to do is you have to apply the correction factor. How to apply the correction factor? Correction factor is nothing but the lower limit of the class. Lower limit is which? That is the highest value, 20 minus 19. 19 is of the preceding class divided by 2, which is equal to 1 divided by 2, which is equal to 0.5. So now you got the correction factor. So first what you have to do, for the lower limits you have to subtract 0.5 and for the upper limit you have to add the 0.5. So you subtract with lower limit. Lower limit is what? 10, 20, 30 and 40. These are your lower limits. You have to subtract. 10 minus 0.5 will give you 9.5. 20 minus 0.5 will give you 19.5. 30 minus 0.5 will give you 29.5. 40 minus 0.5 will give you 39.5. Similarly, you have to add for upper limits. Which are the upper limits here? 19, 29, 39 and 49. So for 19 you add 0.5. 19 plus 0.5 will give you 19.5. 29.5. 29 plus 0.5 will give you 29.5. 39 plus 0.5 will give you 39.5. 49 plus 0.5 will give you 49.5. Now you arrange them how it is you have written in lower limit and upper limit. So similarly write class intervals will be of, in the exclusive form it will be of 9.5 to 19.5, 19.5 to 29.5, 29.5 to 39.5 and 39.5 to 49.5. So this is your new exclusive class interval. So this is the way how do you convert this from inclusive class interval to exclusive class interval. Very important problem. Next is open end classes. What do you mean by open end classes? In a class, if lower or upper limit of a class is not specified, if the lower limit or the upper limit of the class is not specified, such a class is called as open end class. For example, less than or below or more than above a particular class limit. You see the example there. Open end frequency distribution, class interval and frequency is given. class interval less than 20 and frequency is 8, so on it continues at last up to more than 60 up to the frequency 3. So you can see in the class interval less than 20. So this is, it doesn't confirms the end of the class interval, whether it starts from 0, whether it starts from 10, it is not confirmed there. So it is mentioned only that it is less than 20. So below 20 all the values are to be frequency with the 8. So above 60 there are only 3. So above 60, that is more than 60, there are many, but they have not preferred the upper limit of that. So these type of class interval, this type of frequency, if you find, these are called as open end classes frequency distribution. Next is midpoint. How to calculate midpoint? This is very easy. The central value of a class is called midpoint. The central value of a class is called as midpoint. It is abbreviated as m or x, which is equal to lower limit plus upper limit divided by 2. So midpoint is calculated as a lower limit plus upper limit divided by 2. For example, midpoint of a class 10 to 20. Midpoint of a class 10 to 20, it is calculated as a lower limit plus upper limit divided by 2, which is equal to 10 plus 20 divided by 2, which is equal to 30 divided by 2, which is equal to 15. So hope you understood what is the midpoint. Next, width of a class. What do you mean by the width of the class? How it is been calculated? The difference between the upper and the lower limits of a class is called width of the class. The difference between the upper and the lower limits of a class is called width of the class, and it is denoted by C or I. Then it is denoted by C or I. For example, the width of the class interval 30 to 40. The width of the class interval 30 to 40 is calculated as 40 minus 30, which is equal to 10. So 10 is the width of the class interval 30 to 40. See the calculation, how it is done. Width is calculated as a difference between the upper limit and the lower limit. Upper limit UL minus LL. So upper limit of 30 and 40, class interval is, upper limit is 40 and lower limit is 30. So 40 minus 30, which is equal to 10. So 10 is the width of the class interval 30 to 40. Next, to calculate the number of classes. The number of classes can be obtained by using Professor Sturge's rule. To calculate the number of classes, we are using the Sturge's rule. Number of classes k is equal to 1 plus 3.322 log n. Number of classes, capital letter K, is equal to 1 plus 3.33 into log n, where n is the number of observation. The width of the class can also be obtained by width of the class C is equal to range divided by the number of classes. It can also be obtained as a range divided by the number of classes. Next, cumulative frequency. This you already know what is cumulative frequency. In your 10th standard you have learnt that is less than cumulative frequency and more than cumulative frequency. The added up frequency is called as cumulative frequency. What are cumulative frequency? The added up frequency is called as cumulative frequency. There are two types of cumulative frequency, that is, first one is less than type and second one is more than type. The number of observation below a certain limit is less than cumulative frequency. The frequency distribution formed for less than cumulative frequency against the upper class limit is less than cumulative frequency distribution. The number of observation below a certain limit is less than cumulative frequency. The number of frequencies above a certain limit is more than frequency, more than cumulative frequency. Now we shall see the example and understand. frequency distribution is given weight, number of persons, 30 to 40 10, 40 to 50 15, 50 to 60 20, 60 to 70 15. First you have to form the less than cumulative frequency. Less than cumulative frequency, how to form? First value you have to write as it is 10. For the next one, add 10 plus 15, you will get 25. 25 plus 20 will be 45. 45 plus 15 will be 60. Less than cumulative frequency calculation. First write from the question as it is the frequency, that is 10. For 10 you add the next frequency, that is 15, so you will get the value 25. For 25 you add the next frequency, that is 20, it is 45. For 45 you add 15, you will get 60. For more than type frequency, you start from the last, that is from 15. See the question here, it is 15, start from 15. 15 plus 20, it will give you 35. 35 plus 15, it will give you 50. 50 plus 10, it will give you 60. So these are the two types of cumulative frequencies. They are nothing but less than cumulative frequency distribution and more than cumulative frequency distribution. So here I wind up today's session. Thank you.